Welcome to Unacademy. Let us crack GATE ESE ME. This is Umamaheshwar Rao. This batch is regarding Super Talent Batch for Engineering Sciences. Unacademy GATE and ESE presents free classes by India's top educators. Umamaheshwar Rao. Scan QR code to watch now. Link in description below. Unacademy Unlock 20% off on GATE and ESE Mechanical and Chemical Engineering subscriptions. Offer is valid from August 22nd to 26th. Use code KUR75. Unacademy's light distance learning program, test series and printed notes for GATE and ESE in Mechanical Engineering and Chemical Engineering. Use code KUR75 to subscribe now. Unacademy Unlock 20% off on Unacademy Light Distance Learning Program subscriptions from August 22nd to August 26th. Unacademy presents GATE and ESE Combat, a scholarship test to ace your preparation. 20 questions in 60 minutes. Test will be conducted on August 28th at 11 a.m. Enroll now. Unacademy's GATE and ESE Combat scholarship test to ace your preparation. 20 questions in 60 minutes. Rank 1 90% scholarship, rank 2 to 5 70% scholarship, 6 to 10 50% scholarship, rank 11 to 50 30% scholarship, rank 51 to 150 25% scholarship. Test will be conducted on August 28th at 11 a.m. Enroll now. Unacademy is announcing Vision Batch for GATE 2023 in Mechanical Engineering. Batch commences from August 25th in Mechanical Engineering. Unacademy GATE and ESE Iconic subscribers, we have something new for you. Exclusive Iconic Test Series. 5 tests are bundled per branch. More than 140 questions per branch. Questions are prepared by the top educators. Peer-to-peer score comparison. Detailed result report for live test takers. New tests every week. Taylor series and Lawrence series expansion. If f of z is analytic at a point z0, f of z is analytic at a point z0, then f of z can be expressed as f of z0 plus z minus z0 into f dash z0 by 1 factorial plus z minus z0 whole square by 2 factorial into f double dash z0 plus z minus z0 whole cube by 3 factorial into f triple dash z0. Now, if z0 is 0, the series is known as Mclaren series expansion. Now, Lorentz series expansion. F of z is sigma n equal to 0 to infinite a n into z minus z naught whole power n plus sigma n equal to infinite 1 to infinite bn by z minus z naught whole power n. This is general form of Lorentz series expansion. Here an into z minus z naught whole power n is known as analytic part. Bn into 1 by z minus z naught whole power n is known as principal part. Based on this principal part only, we are going to classify the singular points into different categories. If there are no terms in the principal part of f of z, if there are no terms in the principal part of f of z, then if there are no terms in the principal part of f of z, then z naught is called removable singular point. If there are no terms in the principal part of f of z, then z naught is called removable singular point. If there are no terms in the principal part of f of z, then z naught is called removable singular point. If there are infinite number of terms in the principal part of f of z, then z naught is called essential singular point. If there are infinite number of terms in the principal part of f of z, then z naught is called essential singular point. If there are finite number of terms in the principal part of, if there are finite number of terms in the principal part of f of z, then Z0 is called. If there are finite number of terms in the principal part of f of z, then Z0 is called pole. If there are finite number of terms in the principal part of f of z, then Z0 is called pole. Observe, if sin z equal to sigma n equal to 0 to infinite an into z minus pi by 4 whole power n, then a6 equal to. So here, when you look at the general form of the series, we can understand that the series is expressed in terms of z minus pi by 4 by using Taylor series expansion. In Taylor series expansion, in Taylor series expansion, f of x equal to f of pi by 4 plus z minus pi by 4 into f dash pi by 4 by 1 factorial plus z minus pi by 4 whole square by 2 factorial into f double dash of pi by 4 plus and so on z minus pi by 4 whole power 6 by 6 factorial into sixth derivative of f at pi by 4 and so on. Observe, so here a6 is nothing but sixth coefficient of z minus pi by 4 whole power 6. We have to find out a6. a6 is nothing but coefficient of z minus pi by 4 whole power 6. Now, sixth derivative of f at pi by 4 by 6 factorial is required. Now, f of x is sin x, f dash x is cos x, f double dash x is minus sin x, f triple dash x is minus cos x, fourth derivative of f is sin x, fifth derivative of f is cos x, sixth derivative of f is minus sin x. We have to calculate sixth derivative of f at pi by 4 minus 1 by root 2. Therefore, a6 is nothing but sixth derivative of f at pi by 4 by 6 factorial. Sixth derivative of f at pi by 4 is minus 1 by root 2 by 6 factorial is 720. That is nothing but minus 1 by 720 root 2. 720 root 2. Next one. In Lorentz series expansion of f of z, 1 by z minus 1 minus 1 by z minus 2 valid in the region mod z greater than 2, the coefficient of 1 by z square is, what is the coefficient of 1 by z square? Observe. So f of z is 1 by z minus 1 minus 1 by z minus 2. Here mod z greater than 2. When mod z is greater than 2, 2 less than mod z, that is 2 by mod z less than 1. If 2 by mod z less than 1, 1 by mod z is also less than 1. That's why let us take z common. Z of 1 minus 1 by z minus z of 1 minus 2 by z, that is 1 by z into 1 minus 1 by z whole inverse minus 1 by z of 1 minus 2 by z whole inverse. Continuation. 1 by z of 1 minus 1 by z whole inverse is nothing but 1 plus 1 by z plus 1 by z square plus and so on, minus 1 by z of 1 plus 2 by z plus 4 by z square plus and so on, 1 by z plus 1 by z square plus 1 by z cube plus and so on, minus 1 by z minus 2 by z square minus 4 by z cube and so on, plus 1 by z minus 1 by z cancel. 1 by z square minus 2 by z square minus 1 by z square, 1 by z square minus 4 by z, 1 by z cube minus 4 by z cube minus 3 by z cube and so on. What is coefficient of 1 by z square? Observe coefficient of 1 by z square. Coefficient of 1 by z square is minus 1. Coefficient of 1 by z square is minus 1. Next problem. The coefficient of 1 by z in the expansion of log z by z minus 1 valid in the region mod z greater than 1. Mod z greater than 1. One less than mod z. 1 by mod z less than 1. Now log z by z minus 1 we have to express in terms of 1 by z. Log z by z minus 1 log z minus 1 by z whole inverse minus log z minus 1 by z 1 minus 1 by z. Log 1 minus 1 by z is minus 1 by z minus 1 by z square by 2 minus 1 by z cube by 3 minus 1 by z power 4 by 4 and so on, bracket close. Continuation, 1 by z plus 1 by 2z square plus 1 by 3z cube plus 1 by 4z power 4 plus and so on. We have to find out coefficient of 1 by z. Now, coefficient of 1 by z is 1. So, the answer is 1. Next problem. For the function f of z equal to sine 1 by z at z equal to 0 is removable singular or simple pole or essential singular, which one? F of z is sine 1 by z. One by z minus 1 by z cube by 3 factorial plus 1 by z power 5 by 5 factorial minus 1 by z power 7 by 7 factorial and so on. Here infinite number of terms in the principal part of the function. Infinite number of terms, infinite number of negative powers of z. Infinite number of terms in the principal part. Therefore, z equal to 0 is essential singular point. Z equal to 0 is essential singular point. Next, the radius of convergence of the power series of the function f of z equal to 1 by 1 by z about z equal to 1 by 4. Simple. Radius of convergence is nothing but the shortest distance between the singular point and the point z0. Here z0 is 1 by 4 and the singular point is z equal to 1. So the closest distance between z equal to 1 and z equal to 1 by 4. What is the shortest distance between z equal to 1 and z equal to 1 by 4? 3 by 4. 3 by 4. The shortest distance between z equal to 1 and z equal to 1 by 4 is 3 by 4. That's why radius of convergence is 3 by 4. Radius of convergence is 3 by 4. One by 4 and 1. The distance between 1 by 4 and 1. Three by 4. That is radius of convergence. Here, for the function 1 minus e power minus z by z, the point z equal to 0 is, for the function 1 minus e power minus z, by 1 minus e power minus z by z. 1 minus 1 e power minus z is 1 minus z by 1 factorial plus z square by 2 factorial minus z cube by 3 factorial plus and so on by z. That is 1 minus 1 plus z minus z square by 2 factorial plus z cube by 3 factorial and so on by z. This is involving only positive powers of z. Z by z is 1 minus z by 2 factorial plus z square by 3 factorial and so on. Then there is no negative powers of z, therefore it is a removable singular point. It is a removable singular point. Last option is correct. Next one, f of z equal to z minus sin z by z cube. The point z equal to 0 is a pole of order 3, pole of order 2, essential singular point, removable singular point. The function f of z equal to z minus sin z by z cube. F of z is z minus sin z by z cube, z minus sin z, z minus z cube by 3 factorial, z power 5 by 5 factorial, z power 7 by 7 factorial and so on by z cube. That is z minus z plus z cube by 3 factorial minus z power 5 by 5 factorial plus z power 7 by 7 factorial and so on by z cube. Here plus z minus z cancel. If you take z cube common, you will get 1 by 3 factorial minus z square by 5 factorial plus z power 4 by 7 factorial and so on. There is no negative powers of z. There is no negative powers of z. Therefore, it is a removable singular point. F of z is 1 by z square minus 3z plus 2. 1 by z square minus 3z plus 2. The coefficient of 1 by z cube in Lorentz series expansion of f of z for mod z greater than 2. Mod z greater than 2. 2 less than mod z. 2 by mod z less than 1. If 2 by mod z less than 1, 1 by mod z is also less than 1. The function f of z is 1 by z square minus 3z plus 2. One by 1 minus z into 2 minus z. If you take partial fractions, or z minus 1 into z minus 2. A by z minus 1, B by z minus 2. Put z equal to 1. 1 by 1 minus 2 minus 1. 1 by 2 minus 1, 1. Now, If you take z common, 1 minus 2 by z. Now continuation. Minus 1 by z of 1 minus 1 by z whole inverse plus 1 by z of 1 minus 2 by z whole inverse minus 1 by z of 1 plus 1 by z plus 1 by z square plus 1 by z cube plus and so on plus 1 by z of 1 plus 2 by z plus 4 by z square plus 8 by z cube plus and so on. Now simplify this. Minus 1 by z into 1 minus 1 by z minus 1 by z into 1 by z minus 1 by z square minus 1 by z cube minus 1 by z power 4 plus 1 by z plus 2 by z square plus 4 by z cube plus 8 by z power 4 and so on. Now minus 1 by z plus 1 by z cancel. 2 by z square minus 1 by z square 1 by z square 4 by z cube minus 1 by z cube 3 by z cube 8 by z power 4 minus 1 by z power 4 7 by z power 4 and so on. Now the coefficient of 1 by z cube is 3. Coefficient of 1 by z cube is 3. Next problem. Let sigma n equal to minus infinite to infinite a n into z plus 1 whole power n be the Lorentz series expansion of f of z. F of z is sin z by z plus 1. Sin z by z plus 1. Then a minus 2 is observe. Given that we have to express Lorentz series expansion in terms of z plus 1 means let us take z plus 1 equal to t. Z equal to t minus 1. Now the function f is sin z by sin z by z plus 1. Z plus 1 is t, that is sin of 1 minus 1 by t. Sin a minus b is sin A cos B minus cos A sin B. Now sin 1 into cos 1 by t is 1 minus 1 by t square by 2 factorial plus 1 by t power 4 by 4 factorial minus cos 1 into sin 1 by t minus 1 by t cube by 3 factorial plus and so on. Sin 1 of 1 minus 1 by 2t square plus 1 by 24 t power 4 minus cos 1 of 1 by t minus 1 by 6t cube and so on. Sin 1 minus sin 1 by 2t square plus sin 1 by 24 t power 4 minus cos 1 by t plus cos 1 by 6t cube and so on. Sin 1 minus cos 1 by t minus sin 1 by 2t square plus cos 1 by 6t cube plus sin 1 by 24 t power 4 and so on. That is nothing but sin 1 minus cos 1 by z plus 1 minus sin 1 by 2 into z plus 1 whole square plus cos 1 by 6 into z plus 1 whole cube plus sin 1 by 24 into z plus 1 whole power 4. Given that the series is an into z plus 1 whole power n, so we have to calculate a minus 2 value. So a minus 2 is nothing but when you put n equal to minus 2 in the given series, we get a minus 2 into z plus 1 whole power minus 2. That is nothing but coefficient of z plus 1 whole power minus 2. So our job is to calculate coefficient of z plus 1 whole power minus 2. Now a minus 2 is coefficient of 1 by z plus 1 whole square. What is coefficient of 1 by z plus 1 whole square? Minus sin 1 by 2. Minus sin 1 by 2 is the answer. The coefficient of z minus pi whole square in Taylor series expansion of f of z. The coefficient of z minus pi whole square in Taylor series expansion of f of z. Observe here, the coefficient of z minus pi whole square is nothing but f double dash of pi by 2 factorial. So our job is to calculate second derivative of f at pi. Now f double dash pi by 2 factorial. Sir, what is f double dash pi? Now sin z by z minus pi. Please observe. At z equal to pi na. Now if you write sin of, let us take z minus pi equal to t, z equal to pi plus t. Now sin z means pi plus t by z minus pi t, that is sin 180 plus t minus sin t by t at t equal to 0, t minus t cube by 3 factorial plus t power 5 by 5 factorial and so on by t, that is nothing but minus of 1 plus t square by 3 factorial, 1 minute, this is minus 1 minus t square by 3 factorial plus t power 4 by 5 factorial and so on, that is minus 1 plus t square by 3 factorial minus t power 4 by 5 factorial plus and so on, minus 1 plus z minus pi whole square by 3 factorial minus z minus pi whole power 4 by 5 factorial plus and so on. We have to calculate coefficient of z minus pi whole square. Coefficient of z minus pi whole square is 1 by 3 factorial. One by 3 factorial is nothing but 1 by 6. Answer is 1 by 6. In the Lorentz series expansion of f of z equal to 1 by z into z minus 1, when mod z minus 1 greater than 1, observe here mod z minus 1, let us assume z minus 1 equal to t. Mod z minus 1 greater than 1 means mod t greater than 1. Now 1 less than mod t, 1 by mod t less than 1. We have to express in terms of 1 by t. Now the function is 1 by z into z minus 1. Z is nothing but t plus 1. T into t plus 1. Z minus 1 is t. So t plus 1 into t. Take t common. T common. You'll get 1 by t square of 1 plus 1 by t. 1 by t square of 1 plus 1 by t whole inverse. That is 1 by t square of 1 minus 1 by t plus 1 by t square minus 1 by t cube plus and so on. Now t is nothing but z minus 1. Therefore 1 by t square minus 1 by t cube plus 1 by t power 4 and so on. T is nothing but z minus 1. 1 by z minus 1 whole square minus 1 by z minus 1 whole cube plus 1 by z minus 1 whole power 4 and so on. Now coefficient of 1 by z minus 1 is 0 because our series starts from 1 by z minus 1 whole square. That's why coefficient of 1 by z minus 1 is 0. 0 is the answer. Final answer is 0. Understood?